This section of the study pack is looking at the classification and oxidation of alcohols. So by now hopefully you are aware of what makes an alcohol either primary, secondary or tertiary. When we're looking at primary alcohols, we are looking, in this case, C3H7OH, we're looking for the OH group being attached to one carbon that in turn is attached to one other carbon. So this OH group on a carbon attached to one carbon. And so here we have prop-an, 1-ol. We're always going to need this number when there are more than two carbons in the chain. For the secondary alcohol, the OH group needs to be attached to a carbon, which in turn is attached to two other carbons. So we end up with propan, 2-ol. And then tertiary alcohol, this time we're going to need to have more carbons in the structure because we need an OH on a carbon, which in turn is attached to three carbons. This is now going to be 2-methyl, prop-an, 2-ol. So we have a student exercise. Propan, 1-ol, as we've said, three carbons with the OH group attached. That's going to be primary. The OH group is attached to a carbon which is attached to one other carbon. Pent, 2, 3, 4, 5. On carbon number 3 there's an OH group and there's also a methyl group. So the OH group is attached to a carbon which is attached to 1, 2, 3 other carbons. So tertiary. Four carbons in our chain. On carbon number 2 there's an OH group. Always put your OH group on first, and then the methyl groups are attached relative to the position of the OH group. The OH group is on a carbon attached to two other carbons, secondary. Pentan, 3-ol, 3, 4, 5. OH group on carbon number 3. The OH is on a carbon attached to two carbons, so secondary. We can see, therefore, there is no relationship whatsoever between the classification and this number. It's about structure. It's not just about what this number is. 2-methyl-butan, 2-ol, so bute, OH group on carbon number 2, methyl group on carbon number 2 as well, and the carbon with the OH is attached to 3, tertiary. Nice, simple, quick video there.